Greetings, comrades. Now, at some point in your exam revision campaign, I would strongly encourage you to access the VCE study design for Psych, get onto page 12 and 13, have a look at those key research skills. Some of these might have been out of mind and out of sight. They might not have come up in your SACs, but you want to use this as a checklist in terms of basically identifying some of the research methodology concepts that will come up potentially in the exam. The source of some of the images in this revision PPT, our textbook is the Cambridge one, so I have utilised some of their resources. I'm not generating any revenue from this. Not many people will watch it. So again, thank you Cambridge in advance for allowing me to access some of your visuals. Now, one key skill listed on page 12 and 13 of the study design is the ability to write a research hypothesis, not operationalized. So just be mindful about the components of a hypothesis. We need an IV, DV, and a prediction. Now, I'm guessing that you won't be able to read the blurb in this slide, so you can go back onto the VCE website and check this out from 2014, the first question in what was then section C of the exam. So let me just sum it up. So what we have here is an observational learning scenario where we've got members of a tennis club that can access a video that's basically breaking down the mechanics of the service action, and then they're measuring how well they perform that. So in terms of writing a hypothesis for 3 marks, don't worry too much about how you word it. Don't worry about the grammar. The way this will be marked is there an IV in there? And this has a bit of a clue here in terms of the table. So their mean score, what's this mean score represent? Well, that's their mastery of the tennis serve. We don't need to operationalize it. So we don't need to get too numerical. There needs to be an IV. So again, in the table here, it's got Group A and Group B. So then we need to go back to the scenario and work out what the difference is. And it's so whether the participants from Group A or Group B were exposed to the modelled video. And then the prediction is the members who've watched the vid are going to be better at that serving technique than those who've had no access. So therefore, hypothesize that the members of the club who've been exposed to the video will demonstrate greater mastery of their tennis serving action. So again, don't worry about the wording. As long as we've got an IV, DV, and prediction there, you're kicking goals. Now, this question from 3 years back stumped students, as reflected by the stats here. So I won't go through all the options on these various multiple choice questions that pop up, but let's just quickly have a look at B. Predicts how the DV will affect the IV. If we switch the IV and the DV around in this sentence, that'd be an excellent answer. And I think what's happened here is students have just simply been fatigued. Question 17. So something to be mindful of in your revision, given there's 40 multi-choice questions on the exam. If you're making careless errors like this when you're under time pressure, then maybe be mindful about how you structure the exam, potentially doing the multi-choice section in, say, 2 or 3 chunks. So we do a chunk of questions, and then we walk away metaphorically and do some short answer, and then we come back, etc. All right, C is the correct answer. Okay, the hypothesis based on scientific knowledge in order to understand the test ideas. It's not kind of our textbook explanation of the hypothesis, but a process of elimination will get us there. The problem with D is that a hypothesis is not the method of research. It's simply the tool that we used in a controlled experiment to again explore that IV-DV relationship. Now, if you're asked from a scenario to identify IV-DV, again, just be mindful that the IV is the one we manipulate or change. Be careful of a within subjects design, because sometimes students will imply that we have separate groups. So if it is a within subjects design, when you're identifying the IV, you're going to be talking about a control condition and an experimental condition rather than separate groups, which is what we'd have with between subjects. The DV is the one that we measure because we want to figure out how the IV, the change in the IV has affected that DV. Now, I know some of my slides are a bit text heavy. These are the slides that I'm using with my students at my school. So feel free to freeze the screen if you want to just unpack this as I'm verbalizing it. EVs and CVs, students always have difficulty grappling the difference between an extraneous and a confounding variable. There's obviously some common ground here because both are unwanted, both can potentially affect the DV. So with an extraneous variable, this is something that we've identified before we've run the experiment, and we're speculating that potentially this could affect the DV. And that's where controlled variables come into play, because when we identify some of these EVs, then we can employ controlled variables in order to minimize these, eliminate them, and therefore we will get some more valid results. But sometimes we can't do that, or we haven't anticipated some of these variables, and that's when we get confounding variables. So this is where we've already run an experiment, and now we're not sure if this other variable has systematically affected the DV. Be careful on things like sample size. That's not an extraneous or a confounding variable. That simply will reduce your external validity and your ability to generalize your data. But even if you only have a sample size of 5, that is not an extraneous or a confounding variable, because it's not a variable that's affecting one group or one condition more than the other. Now, again, check out the stats on this. This question stumped students from a couple of years back. They've loved the use of stratified sampling to minimize the effect of the CV on the experiment. Now, the problem with this is that stratified sampling is used to make our sample more proportionally represented, so that we've got all our minorities represented in a sample, but it doesn't control for confounding variables. So therefore, this draws us to see if we randomly allocate our participants into our control and experimental conditions, then we're basically improving the odds that our participant-related variables are going to be spread across our two conditions. So again, with stratified sampling, that is basically so we're getting a proportionally represented sample. So let's reinforce that further by looking at a sample exam question. So from VCA, in an experiment, it's essential to control for EVs so that A, there's a probability that the results will be obtained by chance. No, we actually want to reduce the likelihood that the results are due to chance, because that's going to undermine the validity of our findings. B, a valid conclusion can be drawn about the effect of the manipulation of the IV on the DV. That's a good, robust explanation there. A valid conclusion can be drawn about the effect of the DV on the IV. So again, look out for that, I guess, fatigue when we're working our way through these multi-choice questions, because again, the opposite's true, as reflected by B there. And then D, the hypothesis is supported and the results of the experiment can be generalized. Well, look, we're not going to support all our hypotheses just because we've controlled for EVs, because we might get results that are the opposite to what we expected and predicted in our hypothesis. So in that case, we'll reject our hypothesis. So again, just be careful on the play on words there. Now, when it gets to sampling, a couple of concepts to be really mindful of. First of all, we start with a population of interest. So that might be people who suffer from a phobia, or who have a suspected case of Alzheimer's, or it might be a group of teens who are suffering from delayed sleep phase onset. Our sample, because we can't test everyone in our population, is a subset of that population of interest, and there's different ways of generating a sample. Ideally, when we're running a controlled experiment, our sample is representative of our population of interest, so that basically we can again spread out those participant-related variables and generate externally valid findings. Ideally, our sample is large, not always practical depending on our access to our population, how big the population is, our resources, etc. So there's two sampling techniques listed on the study design, random and stratified. Sometimes we talk about convenience sampling, but that's not listed on the study design, so that is not fair game for the exam. So random sampling, three things we need to be able to do with both techniques: explain how we can implement it and discuss a strength compared to the alternative method and a limitation. So random sampling is simply selecting participants from the population so that every member of that population has an equal chance of being selected. So the advantage of going with that process, particularly if we have a large sample, is that our sample is more likely to be representative of our population of interest, which enhances our external validity. The problem is that it's often difficult to actually access a database of that population, so it simply might not be practical. Check out this retro question, which requires students to do a bit here. So we've got a basketball league with 1,500 registered players, and the command terms of the question is asking us to explain how research could design a random sample procedure to investigate the effect of sports drink, e.g. Gatorade, on the performance of the under 16 players for 3 marks. So 1 mark for simply referencing the population. We've got 1,500 Sunnydown Basketball League players. Second mark was for explaining how we could generate a random sample with a few specifics. So we could have gone old school and just write down 1,500 names on a bit of paper, put them in a hat, and then pull out 100 or 50 or whatever. Or we could go new school by coming up with some type of program, and in Excel can do that. So don't need to get too specific there, but as long as we mentioned that the method gave every player an equal chance of being selected. Then the third mark, and a few students missed this, and it was a quirky question, was explaining that those 100 players, or 50 or 30 or whatever, would be then required to drink their Gatorade to determine the effect on their performance. So my point there is look at the command terms of the question, make sure you clearly link it to the scenario and address those command terms in terms of explaining what random sampling is in this case. Okay, then we get to the other technique, stratified sampling. So what do we mean by stratifying, and what are the pros and cons? So stratifying is when we're basically concerned that minority groups are not going to be represented in our sample. So therefore we divvy up our population into strata. Now the strata could be gender, if we've got a gender imbalance. It could be based on ethnicity, it could be based on age groups, it could be based on some form of status in terms of leaders, managers in an organisation, etc. So as long as we're going through a process where we determine the numbers of and our proportions of each sample, and then we get to the next step, which is basically selecting members from each strata group so that we're proportionally matching that minority and majority group in our sample to match the proportions that we have in our population. So the advantage of that is we get a representative sample. All our minority groups are represented in the same proportions. The limitation is there's a time and cost that is involved in terms of that stratifying process that makes it more costly and time consuming than if we just went with random sampling. Now, in the study design, one of the key skills is selecting an investigation methodology. and there's multiple options here. And if you're asked to evaluate any of them, then you need to point out a strength and a limitation compared to alternatives. So controlled experiments, we should be pretty familiar with those. You've been doing those for the last 4 to 5, 6 years of your scientific careers. So when we're explaining what a controlled experiment is, it's simply an experiment done under controlled conditions where we manipulate an IV to see how it will affect another variable, our DV. So the advantage of conducting a controlled experiment in order to generate findings and an understanding of research phenomena is that because we are controlling those conditions, we can basically make a cause and effect statement about the manipulation of one variable and how it affects the other variable, the DV. If we have a large sample and if we have ensured that we don't have any controlled variables, then we have good external validity and we can apply our findings, our implications to the broader society. But a controlled experiment has its limitations, apart from the fact that it's not always practical. Like, for instance, if you think about the mental health area study at the end of the course, is it ethical to test people that are at the mental illness end of the continuum, or if they've got a phobia, to do research, let's say, on CBT or systematic desensitization? There's also a degree of artificiality when we involve people. They know they're being tested in terms of, I guess, the authenticity of their responses. Now, be careful when you're asked about the allocation of participants. That's not the same as sampling. Sampling is where we basically, I guess, recruit participants from our population of interest. Allocation is the next step. If we're not doing a within subjects design, if we're doing between, then we allocate our participants to a control condition and an experimental condition. If we're doing that randomly, everyone's got an equal chance of being in either group, as opposed to if we did it non-randomly, which might be based on surnames. A to M, you're in the control group. N to Z, you're in the experimental group. That would be non-random because we're not giving everyone an equal chance. Another retro question, this one's asking about the purpose of a control group as it relates to an experiment where they're using mnemonics to see how that will enhance the recall of 5 words. And so because it was only a 1 marker, I think students were lulled into thinking a generic response would cut it, but no, we needed to clearly link the response to the scenario. A good buzzword to use here when you're explaining a control group is that it serves as a baseline measure, and then just link it back to the scenario in terms of the IV. So it's a baseline measure for comparison of the recall of those 5 words in relation to mnemonics. Now, when we're using a controlled experiment as our method of investigation, we've got 3 options in terms of how we utilize our participants. And so with our 3 investigation designs, we need to be able to, again, explain how we can implement this and evaluate. So with a between subjects design, we simply split our sample into different groups via random allocation. And so a strength of that is we don't have to worry about attrition, because unlike a between subjects design where we might have someone do a control condition and then they become ill and they have to pull out and they can't do the experimental condition, then their results become void. We don't have to worry about this. We can test both groups simultaneously, and even if we don't have an equal number of participants, that's okay. The limitation is this opens itself up to participant-related variables having a major effect on the validity of our data, particularly when we contrast it to a within subjects design. So a within subjects design, I did mention before to be careful on this one. because historically what students do is when they're unpacking this, they imply that it's two separate groups. So what we're doing here is we're exposing our sample to multiple conditions. It might be more than two, by the way, where there's some type of a baseline level that we've measured, and then we expose them to the IV, and then we test them again to see if there's a difference. So the strength that you're always going to go with on this one is that we have totally eliminated the effect of participant-related variables. If it's a memory experiment, mention something like STM capacity. If it's something to do with sleep, maybe measure something to do with their normal sleep requirements, etc. The limitation is that, again, if we have attrition, then someone pulls out at phase 2 of the experiment, then the results from phase 1 are void. So we've got to kind of manage that. There might be an order effect where they've gained some insights from the first phase of the testing, and then that's kind of influenced their performance on the second phase, etc. So we don't have that problem with a between subjects design. And so a mixed design, as the name implies, is a combo of these other two options. So we still have separate groups, but we're exposing them to both a control phase and then an experimental phase. And so think about that. First of all, we can compare the effect of the IV on the two groups, but we can also compare the effect of the IV within the groups. Let's say we did a mixed design and we based it on gender. So therefore we can see if the actual IV has had a more powerful effect on males versus females or the other way around. And so not only can we compare males versus females, but we can also compare by looking at the baseline data, because that might have varied greatly to start with, to see if the IVs had a more powerful effect on males versus females. Now, it doesn't necessarily have to be gender. It could be based on some other stratification. The next type of investigation methodology that's listed on the study design is a case study. So what do we mean by a case study? Well, it's an in-depth investigation of an individual or a group. And the advantage of this is that there's no artificiality. We're not tampering with variables. But the big problem with this is if it is just one person that we're investigating, how can we generalize our results? How can we gauge external validity? And given there's no control of variables, it's prone to a whole bunch of different forms of bias in terms of the way that the data is actually interpreted. The third type of investigation methodology listed in the study design is classification and identification. And if you haven't seen this before, don't take my word for it. Pull out the study design, look it up online, page 12 and 13. Never seen a question on this, so there's no precedent on how VCAR could potentially ask an obscure question on this, but I think we just need to use a bit of common sense in terms of classifying. Think about where this relates to the course. We classify people with circadian phase disorders into either advanced or delayed. We classify people based on whether they have Alzheimer's disease or a specific phobia. Fourth option is correlational studies. So this is where we're basically gauging the strength of the relationship between two variables. And the best way to do that is to bump those variables on a scatter plot, see if you can draw a line of best fit. So potentially we will be able to determine whether we've got a strong positive correlation, where as one variable increases, so will the other one, or maybe we'll have a negative correlation, which is what we had with the alcohol, effects of alcohol and sleep deprivation. If we look at some of the studies there and the performances on cognitive tests, etc. So as the alcohol consumption went up or the level of sleep deprivation, so 17 hours, 24 hours, then the performance went down on those various cognitive tasks, concentration tasks, etc. So the fact that we're working with quantitative data with correlational studies means that we can easily replicate the studies, so we can evaluate repeatability, reproducibility, but it doesn't tell us about the cause and effect that we might get with some of the other options. Then we get to field work, where we're observing and interacting with people in their natural setting. So this is useful for generating anecdotal forms of evidence. It also means that there's less artificiality as opposed to a controlled experiment because they are in their natural setting. But this opens itself up to observer bias. There's also some ethical issues in terms of the informed consent, voluntary participation in terms of actually being observed. So something that we need to be careful of as Okay, a lit review, when some of you get into your tertiary studies, particularly at a postgrad level, you're going to be doing some hardcore lit review. This is often our starting point. So we're getting some secondary data here, and this will give us ideas for generating primary data, because let's see what's already out there in terms of past research and giving us the necessary background intel to help basically direct our research. And so again, with our evaluation, this will help us identify gaps in terms of the science in this area. But again, there's no control over their methodology. So therefore, we've got to be cautious when we're basically utilizing secondary data. Modeling and simulation. So this would be pretty interesting to utilize this for somebody with aphantasia who's trying to generate a autobiographical memory and having difficulty because of the lack of their ability to use visual mental imagery. Also useful if we're testing out people who are under the influence of alcohol or are sleep deprived on a driver's simulation, because again, we can do this in a safe setting. We can simulate the effects of alcohol or sleep deprivation on driving to see how it affects their reaction time, sensory errors, etc. Now, a strength of modeling and simulation is because we're doing it under controlled conditions, we can gauge our repeatability and potentially our reproducibility. Limitation, though, is, again, there's a degree of artificiality. So how close can we make our modeling and simulation to a real world context? Because, again, that's going to potentially undermine the validity of our data. And then we get to product, process, and system development. I'm going to key in here on the process. If we think about the gut-brain axis and we think about the focus on creating good diversity in terms of the bacteria in our microbiota and how important that is for our consequential well-being. So again, if we think about that process in terms of emphasizing the, consumption of prebiotics, probiotics, etc., and then the consequential impact of that on mental health, there's a process there in terms of the development of a system that we need to basically promote to society. So given this clip has been going for half an hour, which has probably cured your insomnia, I'm going to pull a pin on this one, and then I'll create a part 2, which I'll put in the link to this video. So farewell.